What is up, most distinguished patrons of this channel? So for today's video, we're going to be diving into a topic that I've covered in bits and pieces over the years, but I thought I could do it a little bit more justice and answer a bunch of questions that I've been receiving regarding it. So what we're going to be covering is 6010 roots, 7018 fill and cap, and we're going to not so much talk about it on pipe, but on structural or repair or stuff you might do in your home shop or for your job. So with that said, let's get into it. So one of the interesting things with stick welding is you have a variety of different rods and they all kind of serve a different purpose. And you guys got to remember that stick welding has been with us for almost as long as electricity has in practical sense. So at one point, the only option we had to weld was oxyacetylene and more or less stick welding. So to get the performance for particular applications, smart people far smarter than me came up with the idea of using different fluxes on the rods to get different weld pools. And what I mean by that is like 6010, like I have here, is a fast freezing rod. It allows you to weld like holes, big gaps, we'll call it subpar material, aka rusty, painted up junk, and deposit decently strong welds. That's 6010. Well, 7018 is a tool for a completely different purpose. I mean, yes, they're both welding rods, but 7018 is a much stronger rod in practical uses. However, its weld pool's so liquid that it tends to not fill gaps or holes nearly as well as 6010. It does not have as much penetration as 6010. And because the weld pool doesn't freeze as fast as 6010, the 7018 tends to be a little bit harder to weld uphill for most people. I mean, well, I guess that really depends on your skill level. But anyways, the common question, and I've gotten asked this quite a bit, is what's the deal with a 6010 root and a 7018 fill and cap? Now, in piping, that's very common. For example, I'm now a certified pipe welder, and for the last couple months, I've been cranking out a ton of 6010 roots, 7018 fill and cap on pipe, and it works great. It's been with us since probably prior to the 50s. So it's a great process. It's plenty strong for depending on application, etc. You get the picture on it. But the thing is a lot of people apply that to things other than pipe, aka fillet welds, such as something like this. Very common for people on the home, ranch, farm, whatever, to do a 6010 single pass as a root pass and then cap over it with 7018. And the thought is that makes a stronger weld than just welding it all the way out with 7018. And the truth is that, well, that really depends as to whether it's stronger, which is why in this video, we're going to be tackling the key points around this. So that being, is a 6010 root stronger than 7018 on a fillet weld? We're going to answer that and we're going to deep dive into that. We're also going to look at reasons why you might want to use 6010 for a root pass and not 7018. We're also going to look at reasons why you would not want to use 6010 for a root pass and ways to get around the fact that, well, if you want higher penetration, a lot of reasons why they use 6010 is, well, you know that it's going to bite in and melt that root together pretty deep. There's ways to get 7018 more or less, not more penetration, but further into the metal, such as forms of beveling. And we're going to be talking about all of that. So with that said, the first thing that we need to do is do a quick book learning to understand what's really going on here. And then we're going to get to the testing. So right away, we need to understand that 6010 has more penetration than 7018, which most of you are probably aware of that. The reason is pretty simple. The flux coating on the rod produces CO2 gas, and that gas requires more voltage in order to maintain an arc. Therefore, at the same arc gap with both rods, you will have a much hotter arc due to the higher operating voltage. That combined with the fact that 6010 does not have metal powder like iron powder in the flux, it does not deposit any metal from the flux itself. 7018 does. So in a nutshell, 6010 runs hotter and deposits less metal for that amount of heat that it's inputting. Therefore, that heat goes to melting the root. Another way to look at it would be as if you were to do MIG welding and set your wire feed stupidly high without a lot of voltage, you're just going to pile the weld up out of what you're welding. Like if this is the joint, it's just kind of going to keep piling up outward, and you're not really going to get much penetration beyond a certain point. You're just putting more metal down, but that metal isn't melting. 6010 is like a very high voltage, low wire feed for you guys at MIG weld. Anyways, 6010 without a doubt has more penetration than 7018. The weld nugget of 6010, and we'll actually look at a test where we'll see this, tends to be very deep. It tends to have a round ball near the center of the root, and in this case, which this isn't to scale, it typically has 2 to 3 times the amount of penetration of the 7018 rod. 7018 welds, like depicted here, tend to be decent sidewall fusion, and it tends to get in just past the root of the joint, so it does melt that root in, but it's not like what 6010 is, where it's often like on a 1/4 inch plate, you're at least an 1/8 inch in, if not more, through that plate when you weld it from one side. So there really is no comparison there. Now, to help understand whether or not that penetration increase is actually a benefit to you, we need to understand what it does. Very simply, the further that this penetrates and fuses in gives you a bigger weld. When you look from this point to this point, that's called the throat depth of the weld. This is far bigger than this guy. Okay, so by having more fusion, more penetration, it's effectively like having a larger weld. So yes, on face value, a single pass with 6010 versus 7018, a 6010, depending on how it's being stressed, could indeed be stronger, despite the fact it's a lower tensile strength rod. And what I mean by that is, if you were to weld a fillet weld like this and you only had access to weld one side of it, so you couldn't come and put a fillet weld on the other side, if this plate was bent this way, a single pass from 6010 would likely take more force to tear and break through that weld than 7018 would, despite the fact that that is a weaker rod. And the reason is very simple. That extra penetration in here, like I said, increases the throat depth, but it also reduces the leverage. As this plate bends over, it has to tear all the way through to about this point, and then it actually uses this weld as a fulcrum point, and then it tears up either through here or up the toe as this bends this way. Well, having to tear through all of that material, despite the fact it's kind of weaker, will take a lot of force. Now, with a 7018 weld, and you'll have to mind my crappy drawing, where you don't have a whole lot of root penetration, you can see where as this plate gets bent this way, it only needs to tear a little bit in, and now it can start using that weld as a lever and pivot right across there, which is going to be, despite the fact it's stronger in tensile strength, the leverage effect on that will cause that to fail easier. So in a nutshell, what I'm getting at is on a single pass fillet weld where it's being stressed away from the face, it's entirely possible that 6010 will be stronger than 7018. Now, there's ways to get around this issue, one of which is you could put more weld on this, so you fill it out to here. Now your throat depth of your weld is equal in size. This will help. Now, this isn't a smoking gun because the leverage effect, it's still better to have some of the plate fused underneath, but this will significantly help. Another solution you would have is to do a proper bevel on something like this that's kind of not really steep, nothing like, say, like this, because you're never going to fuse this in here, but something like this here. And by using the 7018 and getting some of that weld in here and then welding it out, now you have reduced the leverage because effectively your weld is in as far with 7018 as 6010. So what I'm getting at is it all depends on the way that the weld is stressed, whether or not you're welding both sides of it, the design of the joint, etc., as to whether or not 7018 can be beaten by 6010 in strength. Now, one thing that 6010 will never beat 7018 in is if this is welded out like this and you bend it to where the weld is being stretched. So this is getting stretched. 7018 is significantly stronger than 6010. As a matter of fact, I'll grab a weld to show you. Here's a single pass 7018 weld that was done on 3/8 plate that I bent in a previous video, and it had no problem handling that much of a bend. Now the upper toe of that's starting to crack or stretch a little bit, and that's going to be a given that, well, this is only a single pass, but it is incredibly strong. 6010 will never be able to handle this kind of stress. Even as a 3, 4, 5, 6 pass weld, it will fail, it will crack. It is brittle and less strong than 7018. So in that case, no, 6010 will not replace 7018 for strength. Let's go through a quick list to give you an idea of my opinions and thoughts on when to use it and when not to. So 6010 root, you could use that on subpar material. And by subpar material, I mean something rusty, painted, you get the picture. If it's just junk material, like maybe a concrete dumpster or something, good luck trying to use 7018 and getting things fused together. So in that case, you know, minimal prep work, using it as a root pass, grinding that root pass flat, or at least trying to knock the high spots down and then welding over it with 7018 might just be the ticket to get a good result to where you have a very strong weld that won't fail. Because you guys got to remember, if your root pass is complete junk, inconsistent, full of slag inclusions or voids, that's not good, and 6010 can really help you out in that respect. Non-critical work, and what I mean by that is if it's for some part for a tractor that goes in the ground to till a field, that would be what I would consider a critical. Non-critical would be, I don't know, again, a concrete dumpster, lawn and garden equipment, something where you know that the weld strength is the least of your worries, can work great on that. Open gap. 7018's puddle is so liquid that it tends to be very, very difficult to weld an open gap. You more or less have to layer it until they're almost touching and then weld it. And even then you tend to have a lack of fusion. So open gap 6010 works great. It gives a reliable reinforcement on the backside of what you're welding. Again, that depends on your skill, but I can guarantee you welding with 6010 on an open gap for most people would be easier than 7018, especially on any gap bigger than, I don't know, 3 mil, 1/8 inch roughly and bigger. That would be the way to go, again, on non-critical stuff. Thinner material. So this is more of a 6011 job for thinner material, but 6010 can work. And what I mean by that is you can always run downhill to reduce the penetration of this rod on thinner stuff like sheet metal, like 1/8 inch, 3.2 and under. And that can really help you weld that stuff. And you don't really need the strength of 7018 because that material will never be able to stress the weld enough to cause a failure due to the difference in strength between 6010 and 7018. Now, when I wouldn't use them, number one thing, higher strength materials. Anything on an excavator, a skid steer, a dozer, a farm implement probably needs a strength of 7018 more so than something like a dumpster. So anything that could be or is known to be higher strength materials, it should not be used. 6010 should not be used. Now keep in mind, 6010 is not a low hydrogen rod. 7018, if you use it fresh out of the pack or properly stored in a rod oven, is low hydrogen. And what I mean by that is it does not impart hydrogen, aka H2O water, moisture into the weld pool. On higher strength alloys, that can be critically important because the 6010 welds can crack under stress, or even as the weld is cooling down, it can underbead crack due to the hydrogen. So again, higher strength materials, you have no business putting 6010 in it. Thick material as well. A great example would be, say you had like a 1-inch thick, I don't know, some piece of an excavator, or we'll just say some real thick material. Using 6010 for a root might actually be a bad idea, even if it's mild steel, simply because that steel is so thick that it can impart enough stress on that weld to where the difference in strength might actually be significant enough to cause a failure. And again, this kind of goes back to more of an engineering thing where if you're welding 1-inch thick steel on a fillet weld, let's say, you could always do a pretty, wide bevel and weld it out with 7018 and achieve all of the penetration under the plate that you would want for reinforcement and a proper weld throat depth, simply, like I said, by beveling it. So to me, you really have no business using 6010 on thicker material. The last thing I'm going to share is we're just going to quickly talk about why it's used on pipe. So depicted here is a piece of pipe, kind of like you're looking down through it. And most pipe joints are joined, well, two ways. A socket weld, where you have a fitting that slips over the pipe and then you weld it kind of like a 360-degree fillet weld. And the more common way, especially with pipe bigger than maybe 2.5 inches, would be a open root beveled joint, and that looks something like this. More or less, you put a small landing or an edge on that, you square it up about 1/8 inch or 3.2 millimeter. The rest of it is beveled out, and your first root pass is done with 6010, which is this guy right here, and then you fill it out with 7018. That is very common on pipe. Like I said earlier, I'm a certified pipe welder, and that is what I've been doing for over a month straight now, and it works great. But you have to understand that piping is a very unique process that doesn't really have a lot in similarity to what you might be fabricating at home. And what I mean by that is simple. One, most people do not bevel both edges in a butt joint and then open root weld it. That's very uncommon. Most welds that you might do, say on a project car or something else you're working on, are more or less fillet welds where you have a joint something like this. Even roll cage tubing, for example, typically fillet welds or lap welds. Butt welds are very uncommon. And secondly, when you look at pipe, pipe is meant to hold liquids or gases or whatever have you under pressure typically. So the pressure comes outward. If it's under pressure or if it's at zero pressure, markers, junk. And pipe is not typically done for structural purposes. Therefore, having a 7018 weld all the way around the outside with a 6010 root provides an incredibly strong joint that will resist any kind of pressure you might have, because that root pass down here never sees the stress of what a root pass might see on a fillet weld. Therefore, you can get away with that, and it makes sense because 6010 gives you far more control to weld an open root than 7018. And that is why the 6010 7018 combo is used on pipe, and it works great, and why you shouldn't just arbitrarily apply this to anything you might fabricate, because pipe is not typically structural. It does not handle stresses like something you might weld. Therefore, what you can do on pipe is not necessarily what you should be doing on everything else. Hopefully that makes sense to you. Now let's get to some testing. So we're going to brake test these welds. Both of these were done on 3/8 plate. This guy was done with 6010 1/8 inch rods, 90 amps. This guy was done with 332 7018, 90 amps. One of the great things with these rods, even though this rod was a smaller one, they run at the same amperage, which is another reason why these are very popular for welding on pipe. Very common to use 1/8 inch rods for a root and then fill it out with the 332, so that works really good. Anyways, in this test, I'm going to chuck them in a vise and break them towards the face, and you can see there is no weld on the backside. And I have a feeling, despite the fact that these are the same, like appearance-wise for weld thickness, I have a feeling that the 6010, despite being a weaker tensile strength rod, that it will actually perform better in a bend, aka a break towards the face, simply because the effective throat depth due to that penetration is bigger, aka we have more metal attaching it, the top piece to the bottom piece. So this is should, keyword should. There's mistakes all the time on this channel. Look at the name, it's all in the name. But anyways, let's go chuck this up in the vise and break them and see what happens. So I have my torque measuring device here, and for all practical purposes, this is only a comparison between these two. Don't try and use this information as far as what this reads is like some kind of gospel. We're just doing a comparison test, and rather than me just telling you that one took more force than the other and you don't believe me, this gives us at least a hard number to show that yes, indeed, one of these took more force than the other. With that said, we're zeroed out. Let's bend this towards the face. And it broke at 69 something. It already cleared itself because, of course, it's a Harbor Freight tool, so it's a little bit finicky. All right, I'll go and grab the 7018 and chuck it up in here. All right, I got the 7018 weld. Let's break that. And it broke at 66, which again, of course, it cleared itself. So a little bit weaker, which I would have expected a little bit bigger of a spread there, but it did break. Let's go and look at these on the bench. So the 6010 weld is on the left, the 7018 is on the right. Now the 6010 did break at a bit higher, and realistically this is a very small sample size, so it's hard to jump to conclusions, but I can tell you based on all of the other break tests and bend tests I've done with these rods that typically 6010 will outperform 7018 in this particular weld test. Now, how relevant this weld test is to something that you're actually making really depends. But at least it's food for thought to realize that just because a rod is lower in tensile strength doesn't necessarily mean that it's weaker in practice. And a lot of that has to come down to more or less the engineering behind what we're doing, aka how the stress is applied becomes more of a concern than the actual strength of the weld. With that said, looking at these, the differences are subtle, but they're definitely there. The biggest thing that I notice is that the 7018 weld is not fused at all at the root beyond basically right up to the edge of the plate. I mean, the original edge is completely there, and the effective throat depth of it is basically less than the 6010. Now, it probably doesn't look like it, but the 6010 actually did bite into this plate quite a bit. The original edge of the plate is more or less up higher, and it broke down that edge pretty good. The end where it runs hotter simply because there's nowhere for the heat to go, it melted in further just like 7018, but there is no question that this penetrated further in. Now realistically, 3/8 plate needs a lot more than 90 amps that I ran both of these at, so had I been up at 100 it would have helped a little bit more for both, but I have a feeling 100 amps in a higher dig setting with the 6010 would have given even more penetration. I more or less ran these like stringer welds and didn't, really cram the rod in with 6010 to try and achieve more penetration. But looking at these in person, hopefully it comes out in camera, yes, indeed, 6010 has more penetration. And yes, indeed, the effective throat depth of a given weld will likely be better with 6010 versus 7018. So in that case, no, technically in this test, you are not losing strength welding it with 6010. However, had I bent both of these away from the face, like in a shop press, there is no question that the 6010 would have failed and the 7018 would have bent fully on this plate without failure. So again, it all depends on how something is being stressed, how the weld is being stressed as to whether or not it would hold up in your application. All right, let's look at this other test weld that I made. So for the second test, I did a larger fillet weld and more or less just changed what I did with the roots. So one side is 6010, the other side is 7018. Both sides have 2 beads of 7018 to cap it off. And the finished welds basically look identical. Like I would never know that the internals of them would be any different from one another. They're the same size and look identical. So with that said, let's look at the inside of this because I cut it and etched it and see what we have going on. So here's an up close of the weld on what it looks like on both sides. It's about as clean as you're going to get for a 2-pass cap on something. I don't think I even need to label which one is the 6010 root. I think it's pretty much evident that the one on the right is. Now when we look at this, the 7018 3-bead on the left actually doesn't have that much penetration. It's basically right at the sidewall, and then a little bit past it, the root has basically fusion, but nothing past that. I'll put up a set of grid lines so we can see it a little bit better. So these lines are a little bit misleading. The penetration on both of these is actually a little bit better than what you see here, especially because we have the thickness of the lines. But there's no question that that 6010 is biting farther in. Now, had this material not been clean and full of rust, paint, and anything else you can imagine, I bet that the 6010 would still penetrate as far as what you see here. 7018 is generally very reliable with achieving just root fusion like you see in this picture, but surface contaminants can slightly lower penetration, but this is going to be typical of a 7018 weld on the left. Now, there really isn't a whole lot of sidewall fusion, and I have a feeling if I would have ran around 100 amps on the machine I was running, I would have got slightly better. But again, these are typical welds. You guys also have to remember that a fillet weld like this, due to the 90-degree angle, forces a lot of weld material to build up because it can't flow out or spread out as much as like a beveled pipe where you're running, a shallower angle. And that's one of the reasons why, like on pipes, when you do open root beveled butt welds, that the bevels, both of them combined, are more open than this. That gives the slag and the flux ability to flow out, and it also reduces the thickness of the weld material. When you look at the root all the way to the throat of the weld, like the surface, that's pretty thick, and when you're trying to weld through that much molten material and have that arc heat up that root, you're just not going to get a whole lot of root fusion doing that. Now, as far as does the increased penetration matter? Well, if you only had access to weld one side of a fillet weld, yes, it would matter. It would reduce the leverage and increase the overall strength, despite the fact that it's a weaker initial root pass. And one thing I didn't account for in this testing that is a serious concern is that 6010 welds are far more brittle and less ductile than 7018. Therefore, that root pass in there, even though it's more penetrated, and in the brake test we saw it broke at the same or higher strength, if it got cyclical loading, like say 80-90% of max, or excessive vibration over time, my guess is a 6010 weld will fail long before the 7018 due to that lack of ductility in comparison to it. So a static strength test where we just load it up till it fails is not really accurately representing the differences, and that's the primary reason why I really wouldn't recommend using 6010 for a root on things that require higher strength. It's in your best interest to find a way around the lack of root penetration that 7018 has. Like, you could always fully weld something out with an open root with it, or even closed root, and back gouge it and then re-weld that. I mean, there's so many ways to get around that. If you need strength, you really need 7018. So as you saw, the penetration differences are kind of night and day. The bend test, brake test here kind of didn't really show it in a way I think that you guys would understand it, because what we're not really looking at that cut and etch, that side shot, the profile shot, but this definitely should have cleared that up for you. 7018 in this test didn't penetrate much, but it did at least fuse just the root, and that's pretty typical of 7018 on thicker plate. It's a very strong welding rod as far as the welded deposits, but the penetration tends to be just there, which, I mean, it's reliable in being just there, so that's a good thing. And it's definitely a lot better on thicker plate than the short circuit MIG process, where that you'll often get bridging at the root and absolutely no fusion. And in that case, you can produce very weak welds because of that leverage effect like I talked about earlier. Now, I guess when it comes down to it, should you be using 6010 as a root pass and capping it off with 7018? Well, in my opinion, if I really wanted the most strength, I would have done a slight bevel on this to get that weld further in to the center line of the upright plate, in this case of the fillet weld, and then welded it out that way with 7018 all the way out rather than using 6010. Now, if you're going to be welding on known mild steel like what this is, the hydrogen embrittlement issue with 6010 is probably less of a concern. Therefore, doing this with the 6010 root isn't really a bad idea because you're guaranteed to get root penetration, root fusion. It's gonna be there, guaranteed, which is good because that's a good thing to have on thicker steel, especially on scabby stuff. You can burn in there and get it fused. But the problem is kind of like what I said earlier. You start doing this stuff on high strength steels that you might find on farm equipment or, I don't know, excavators or you get the idea that it becomes a serious concern that weaker root material and the hydrogen that 6010 imparts into this material might cause failures that you wouldn't expect. In those cases, more or less the engineering of the joint and what you're building has more to do with the longevity than the strength of the weld, I guess. But I don't know. I personally, I'll be honest, I tend not to run 6010 much for a root pass anymore, and I do 7018 all the way out on structural stuff, and that's very common in structural welding. You're not going to see a guy coming to a bridge near you running 6010 as a root pass. It's all 7018, 8018, 11018. Like, there's really no benefit in many cases for structural applications of the weaker weld material and the risk of hydrogen embrittlement. But I don't know. It's all food for thought, I guess. So in conclusion, I made this video and left a lot of things open and kind of shared some of my opinions on the matter. But the truth is, I'm trying to teach you guys how to think, not to give you answers. That's probably the most important thing. If you actually want to make welds that are strong and last and fix stuff, you need to be able to think, not look to me or anyone else on YouTube or anyone else for that matter for all the right answers. Because if you can come up with the right answers yourself, guess what? You can actually make solid, long-lasting repairs or build cool stuff without wasting excessive amounts of time looking for the right answer that may actually not be the right answer. Because, like, if anything, I hope this test showed that in certain instances, things that don't make sense, aka a weaker rod being stronger than a stronger rod, can actually be the truth. It's just all in the circumstances that you create. This testing kind of was set up in a way to make 6010 stronger, but in the real world, it very well might not be. And that's why hopefully you gained enough knowledge in this video to be able to make better decisions for yourself, your welds, and your projects. So with that said, if you got any comments, questions, thoughts, feel free to leave them. Otherwise, until next time.